Hi, everybody.
Hi.
Now, if you're wondering, we are. This is the. What do you. I don't know what you call it. The semi penultimate episode? So.
Something like that.
So this is going to be episode 495. We're going to do episode 496 next week, 497 the week after that, maybe 498, and then we go on our summer hiatus. So,
So we're going to be running the exact same dates as the weekly space hangout crew in terms of like which
yeah,
weeks we're here and
yeah,
which weeks we're not.
yeah, we'll match
But
that.
don't fear, you will be getting plenty of summer content over on Cosmo Quest X on Twitch.
Yeah.
So hook yourselves up with Twitch, follow Cosmo Quest X. We are bringing you 15-minute updates on the news Monday through Friday. We have Learning Space, which is kind of the artist's complement to the weekly Space Hangout, where I'm doing interviews of people who took their science and turned it into art, communications, education. So come here, interviews with a different set of people. Um, I guess I'm your arts channel to your, I don't know, I'm going to shut up. I'm bad with this analogy.
Well, the thing is, like, the reason we do this hiatus is because it is like we have to, no matter what, find high speed internet and a good computer and a streaming environment multiple times a week to be able to do this. And it's really hard to have a summer where you do things, go various places, see friends, family, and
And Cosmo Quest is not just me.
and try, well, yeah, no, and then make sure you get yourself back to high speed in your broadcast environment every 3 days.
Yeah.
So I'm off to Australia in July. No plans in August yet, and then actually a ton of stuff in early September. So, and then
I
we
compensate for you in August because I have the IAU.
right, yeah, and so that's why we do it, and it is really kind of refreshing to our brains and good for our energy levels and our enthusiasm, and we've been doing it right from the beginning, I think, or almost from the
Yes.
beginning, and we stole this idea actually from Quirks and Quarks, which is a Canadian show, and they go on a summer hiatus every summer and then come back a couple of months later. But that doesn't mean there's not going to be tons of content. I mean, like you said, you're doing stuff on Twitch.
Yeah.
The 365 days of astronomy is still going out. I'll still be releasing my guide to space, the question shows, the the live QAs when I have the time. Probably going to be doing some live streaming of telescope stuff. So there's going to be a ton of content still coming out over the summer, just not necessarily the scheduled events that we have to find our
Yes.
way to. So that's why we do it. So, but we'll put up we'll put up an announcement when we've switched into that summer hiatus. And then, of course, the whole point is you then join up with the good folks at the WSH crew, and they will keep you entertained and share in your misery over the summer break. So go to wshcrew.space and join that community. Help them plan out who our guests are going to be for the weekly space hangout over the fall. So, all right, are you in a state of pure readiment?
I wouldn't say pure readiment.
Okay.
I think part of me is sad because I need to turn my AC off now.
Okay.
I now have no AC. Okay, let's do this thing. I have pressed record. Hello, Chad.
I have also pressed record. Also, hello, Chad. All right, here we go. Okay, I'm going to need that blurb in a second. Okay, here we go. It's very complicated. You'll see in a second what's about to happen. All right. Astronomy Cast, episode 495, Asteroid Mining Update. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, Dr. Pamela Gay, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific, and the Director of Cosmic Quest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Very well. Now, before we get into today's show, we have an announcement to make. and I have a written announcement here that I'm going to read out so that I get every little piece of data correct. So here we go. There's only a couple of episodes left of Astronomy Cast before our summer hiatus, and that means there's only a couple of episodes before we reach our 500th episode. The 500th episode is going to be recorded live at the beautiful Wildly Theater in
Yes.
Edwardsville, Illinois at Sunday, September 16th. And the WSH crew is inviting everyone to come to Edwardsville the weekend of September 15th and the 16th for a weekend of astronomy-related festivities, culminating in the live recording of the 500th episode of Astronomy Cast. So you'll be able to meet me and Pamela, as well as our families, along with people from the WSH crew and CosmoQuest. In addition to the live recording of the 500th episode, I'm told that we're going to be doing a special live QA episode of my Guide to Space at some point during the weekend, which makes sense. And they will be renting a local brew pub for most of Saturday, where there'll be other things going on. There may even be beer. There's other activities in the works, such as fluid painting of tiny planets with Pamela. Maybe you'll teach me how to do this. Outings to local attractions, and weather permitting, we'll do some stargazing on Saturday night. To register and for more information, head over to astronomycast.com, go to the trips pull-down menu, and click on the AC500 weekend. Pre-registration is now open, requires a non-refundable $50 deposit. And everyone who pre-registers, even if you have to cancel, will receive a goodie bag full of memorabilia from the weekend. And you can pay the full $200 registration fee now, or you have the option of paying $50 now and then paying the balance of $150 anytime between now and August 15th. Hope to see you there. All right, this is going to be fun. 500 episodes.
It's terrifying.
And a huge thank you to Gordon and Nancy and a bunch of the people at the Weekly Space Hangout crew who took it upon themselves to organize this, because neither of us have the energy, have the time or bandwidth to organize anything this complicated. Like, if you can, we will show up and we will stand in front of whatever crowds you put us in front of and entertain, but to work out all of the little details, man, that is amazing, and I really appreciate their help. So let's get on with today's show. Our knowledge of space is starting to match up with our ability to get out there and explore it. And there's several companies working on missions and techniques to harvest minerals from asteroids. What other resources are out there that we can use? Now, Pamela, you put this in as one of our update shows. Have we done a proper asteroid mining show, or are we just doing an episode about asteroid mining? Have we just been binge watching The Expanse, and now it's all we can think about is just harvesting resources from space?
That may be part of it. Although for me, I have to say binge reading the book series. But so we've stuck bits and pieces of asteroid mining in all throughout our shows. But what we've seen since the beginning is we've gone from talking about it as we will capture an asteroid and we will bring it nearby and we will use it to build future spacecrafts, to people are actually going to like fly out and explore them in situ, to we're not using them for any of the things we thought we were going to use them for. So plans have changed, and I think rounding up all the bits of information that we've given over the years that have now utterly changed into one updated episode makes a lot of sense.
Well, and there's a bunch of companies that have formed to do this. There's some really interesting research that's been done. There's of course what SpaceX is doing. There's a lot of work being done in situ resource utilization, which I think could be a whole episode on its own.
Yes.
And there's some gadgets going on board the Mars 2020 rover that are going to help try and figure some of this stuff out. So there is a lot of work across a bunch of different fields to figure out how we can acquire resources from asteroids and other objects in space. So now you had sort of quickly gone over a bunch of ideas there about how we will, we thought that we would like bring some of these samples back to Earth. So can you sort of go through that history a bit? And how we got to where we are now?
So the original picture, and this is the one that I remember growing up on in science fiction, was that asteroids are going to have vast amounts of metals, and rather than having to launch these heavyweight atoms up into space, we're going to fly out and either mine the asteroids directly to get at these precious heavy atoms. So here we're talking about going out and getting iron, getting gold, getting whatever you want to make your spacecraft. And since then we've kind of realized that most space rocks are kind of carbony, kind of like the minerals in your backyard, and not really the kind of stuff that you want to be building your spacecraft out of. This has been a slow discovery aided by sending mission after mission through the asteroid belt. We still only have a handful of high resolution images of different asteroids, uh, but none of them seem to be that solid chunk of 10-kilometer across metal ore that we used to think would be out there.
I mean, they've got to be out there. I've got a chunk of it right here on my desk
Well, so do
right
I. I
now.
have one right
There you
here.
go. There's yours.
I
Here's
found
mine.
mine first.
Yeah, you did.
Yours is bigger.
So we both have a chunk of space metal. So the metal is out there, but not as common as we hoped, and maybe not as easy
It's
to
true.
acquire. Unless you want to go to Asteroid Psyche, which is like this gigantic planetoid made of solid metal, which I do.
But in general, we're looking at most 10% of the asteroid composition across all the asteroids is going to be these heavy metals. So the reasons that we go to asteroids have slightly changed just a bit.
Right. So what kinds of resources now are we thinking we're going to be finding on the asteroids that we can use?
The kind that gets used to fill up party balloons and freeze things to microscopic temperatures.
Helium,
Helium-3.
right? And even just
So
regular helium. I mean, it's
it,
a
yeah,
non-renewable resource that we're just letting off into the atmosphere here on Earth.
yeah. So you're actually, any of you out there watching, listening, you are being extraordinarily irresponsible of our planet's resources every single time you buy a child a balloon, or buy yourself a balloon, or buy someone get well balloons that float on their own. It's fine to buy balloons, fill them with water, fill them with paint, fill them with the air out of your lungs or
Yeah.
out of your bicycle pump.
Fill them with the
Those are
tears of children who don't get helium balloons anymore.
whatever you feel, fill them with. Don't fill them with helium. Don't do the Smurf voice, chipmunk voice thing. All of these things are a waste of a non-renewable resource that we need. So the machine that, if you ever have severe lung issues, that they use to image your lungs, requires helium-3. So if you don't care about creating Einstein condensates, which also requires helium-3, think of your lungs. Think of your lungs. Do not use helium.
Wow. You really are a party pooper.
No, I'm good with parties.
All right. All right. Just don't
I'm
bring the
just
helium.
helium pooper.
Right. So then so where are we going to find this helium out in space?
It turns out, sorry, let me try that again. It turns out that helium is mixed up in the matrix of a lot of different minerals on the moon, in the asteroid belt, in a bunch of different places. So, what we need to do is essentially go out, grab ourselves a chunk of asteroid, and grind it up and see what emerges. And some of what emerges is going to be this helium-3 that we really need.
And so with I mean, we've talked about how like maybe going to be mining from the moon, but is asteroid mining going to be easier? Is it going to be a better way to get at these resources than trying to go and pull it out of the lunar regolith?
Well, so the lunar regolith is perfectly reasonable, but at a certain point, it would be nice to start having that station that we can use that's partway between here and the outer solar system. And the moon is halfway between here and everywhere else. And then everywhere else is a lot more than halfway away. So if we go out and we start working in the asteroid belt, first of all, it gives us a whole lot more places to go. Second of all, they have less gravity to try and escape from. So if you're grabbing the helium-3 there, it's easy to take back off and bring it back.
And what is
And
the benefit of? I mean, obviously, you want to be able to make helium balloons when you're in your space station. But what is the benefit of helium-3 specifically?
it's a highly polarized atom. So normal everyday helium, the stuff that does for the most part go in balloons, there's probably going to be a few helium-3 atoms in there, but the bulk of the helium is consisting of 2 protons, 2 neutrons, 2 electrons. So we have this gorgeous symmetry going on. Now, in many of the minority helium atoms, we have this combination instead of 1 neutron, 2 protons, 2 electrons. And in this 1 neutron scenario, it turns out that we can do all sorts of cool stuff with physics. This is where it starts to become important in imaging because of this, it has a spin of 1/2, and this spin allows you to manipulate it with different magnetic fields. Um, it becomes useful in cryogenics in ways that helium with 2 neutrons is not. Uh, it's basically, it comes down to what can you do in a magnetic field with helium-3 that you absolutely can't do with pretty much anything else.
And one of the other advantages is, should you be able to figure out how to use it in fusion reactions, it
Yes.
doesn't give off as much ionizing radiation as a deuterium reactor or a hydrogen or tritium reactor or something like that. So if you want to have your Epstein drive and you want to have that powered by your helium-3 reactor, not your tritium reactor. So when you think about compact fusion sources, things like that. But of course, this technology of like making fusion reactors we're still waiting for ITER, which is still a couple of decades away. And to then make them out of helium-3 is another challenge. So, in the future, this will be a big source of space power. Now, helium is one, but
Water.
water is the resource that we really have all kinds of uses for.
And this is where it really is that science fiction-y future of, we're starting to come to terms with the fact that the Earth's water probably didn't actually come from comets like we thought. The age of heavy bombardment was rocks, not ice, the way we might have been forced to envision it due to lack of imagination. Now that we've started to measure the ratio of different kinds of water in different comets, we're finding in general they're not the kind of water ratios that we see in our own oceans. And we're also finding, thanks to the Dawn mission, that asteroids are wet. Even the dry ones are wet. And it may be that our oceans are all of the water that was trapped inside asteroids. And asteroids are drier now. They've been baked for a while. So this is sort of like drying wood. It starts out wet and over time dries out, except we're drying asteroids. But they haven't completely dried out. There's still these volatiles, still these ices in there. And this brings us back to my favorite idea, which is the hollowing asteroids out and flying them off to another star system. Here, it can, if we're starting to look at the expanse, we can imagine hollowing them out, sticking colonies in them, sticking them in a Holman transfer orbit so that you can use them to get between objects at different points in time. And you have the water that humans need for so many different things, including growing plants, including caring for livestock and caring for ourselves, uh, all right in the water, locked in the rocks.
Yeah, we drink it, we breathe it, we
Metabolize it.
we metabolize it. It's rocket fuel. So there's all kinds of reasons why water is going to be one of the most useful resources we can get our hands on. Now, there have been a couple of companies that have arisen since we started Astronomy Cast to try to push us towards that future of harvesting minerals from space. So what are some of these companies?
So, Planetary Resources is one that's near and dear to my heart. They crowdfunded their early rockets. The poor company, and this was probably one of my most traumatic moments as someone who teaches science communication. Their Archive 3 original CubeSat that they were using to test some of their technologies actually was exploded on the bad Antares launch back in 2014. And I was doing a live presentation to students on this is how you cover live events when 5 minutes into my presentation, poof goes the rocket. So I know my first email after that experience was to the good folks at Planetary Resources. And what's kind of amazing is 1 year later, July 16th, 2015, they deployed a new version of their rocket. Now, this time they did it in a little bit safer of a way. Um, they launched it and they pretty much pushed it out an airlock, and I'm okay with that.
Right. So what is their sort of current plan? Like when you say, I mean, it was their they have their Arcid. It's like a telescope, really, to be able
Yeah,
to examine
they have
asteroids,
two of them.
and they have two of them now.
So Arcid 3 was the first one. And it was just 10 by 10 centimeters in size. Um, and this is one that, as I said, it was funded through uh, crowdsourcing. So this was what everyone helped make a thing. It tested imagery, it tested the ability to communicate, it tested uh, solar panels, and it did it in a little tiny platform. Now, not one to sit around with only having little tiny, not useful spacecraft when your goal is mining asteroids. They have this long term plan for building up to sufficiently more sophisticated flight tested technology that they feel safe making that first journey to an asteroid. Now, before you go to an asteroid, you try things out in low Earth orbit. Our planet is a rock. A lot of the technology they need, they can deploy examining our particular life having rock. So their next launch was of the Arcide 6. This one flew on one of the Indian rockets, and it is sending back really cool images of our own planet Earth that it's using to do things like detect water using thermal imaging in combination with visual imaging. Um, so they're making the progress they want to make to get to that measuring water future, that mining future. And what I love is they're also growing. So they've gone from a little tiny 10 centimeter across spacecraft to something that is starting to be more of a bona fide suit craft spacecraft. Now they're still not digging, but they have their groundwork laid out for them. And like I said, it's incremental progress that all has to be made before you go out and just start digging into space rocks instead of Earth rocks.
So what comes after? I mean, right now they've gotten to the point where they're able to, or they have their little telescope up in space, and they're starting to categorize and examine some of the objects that are out there. What is their sort of long-term plans for being able to actually mine these places?
So they're working towards their Arcid 301 spacecraft. This is going to be a bigger spacecraft with more sophisticated communications and detection software. And their goal of their initial mission is going to be to identify asteroids that contain water. Um, So it's not going to be go forth and dig, it's going to be go forth and find the water. Now, this is a story that we've heard NASA tell in its exploration of Mars. So we're now starting to see two parallel tracks where we have a commercial space agency picking up that let's go to the asteroid strand while NASA continues the let's go to Mars strand. And both sets of data gathering humans, one called engineers and the other called science, both doing the exact same thing. Uh, their journey is to find the water.
And you've probably heard that there is more resources. There are trillions of dollars worth of mineral resources on just individual small asteroids. The key, of course, is going to be bringing them back to Earth. Have you heard the plan for how they think they might be able to bring, say, a ball of platinum back from an asteroid?
No, this sounds like something again, spacecraft are generally dead to me until they take off
Yeah.
because they like to explode.
So Peter Diamandis, who is the head of the X Prize and is on the board for Planetary Resources, he said they'll spin it into this sort of wool and then have this impact the Earth's atmosphere, and it will slow down just as it comes into the atmosphere and actually be able to decelerate, and it won't burn up because it has this gigantic surface area. So you'll have asteroid, you have meteors.
They're going to make a giant Brillo pad.
Yeah, giant meteors made of gold that will softly re-enter the Earth's atmosphere and land without losing any of its material. And giant, platinum and iridium and things like that. I think it's a pretty neat idea.
There's no controlling where that comes down.
Well, you have your spacecraft go and detach it at the exact right place, but true, it's going to be tough. But as I've mentioned in the past, gravity wells are for suckers. So you want to keep that stuff out in space so you can build your spacecraft and build your future space colonies. Now, Planetary Resources is one. There's another company that's doing this as well. And actually, people in the chat are mentioning a third one out of the UK. So the second one, Deep Space Industries, Rick Tumlinson and team.
Right. So this is another one. What's getting me is the marketing that we see with these two companies, because they're both claiming to be the first to do what they're doing. So they're advertising at Deep Space Industries that they're going to have low cost deep space exploration spacecraft. So the impression that I get of what they're looking to do is they're going to go out, find the stuff, but they're also looking to be the group that will now be carrying payloads for other people. So they're looking to advertise the volume of space that they have on their probes, the typical distance they can go. They're looking at getting to about 2.5 AUs. So we're not quite talking as far as Jupiter, so I question their word deep space, but I am amused nonetheless at their marketing team.
Anything above 100 kilometers is deep space.
It's space.
It's space. It's all from that point on. It's as deep as it needs to be. One of the great things about Deep Space Industries, and one thing that I kind of like about their approach, is they're developing essentially a propulsion system, a platform for these small mineral exploration and eventually retrieval satellites, and then they're finding customers to purchase these. So while Planetary Resources has lots of investments, but also went the crowdfunding way, Deep Space Industries is going this way where they're bringing on customers to purchase the underlying flight hardware for their various CubeSats and things like that. And it seems like a really smart way to sort of scale up your operations and learn how to do this. It's the SpaceX way, right? Where they have paying customers that give them cash flow to be able to continue their development deeper and deeper and deeper, and to sort of be the people that supply the shovels, right? This is
Can we say further instead of deeper?
Sure, farther.
I just have it yeah.
Deeper into deep space. Well, it's Deep Space Industries.
Well,
It's not far space industries.
It should be.
Sure. But I like that idea. There's this great sort of saying, but like when you go up and find out about the gold rush in Canada, in northern Canada, the Yukon, you find out that it was the people that sold the shovels that made all
That
the
really
money.
made out.
Yeah, it was
Yes.
not the people who were searching for gold. It was the people who were supplying the people searching for gold. And I think that's a great way to go. Is these companies are building these platforms that then the people who want to go and try and prospect on an asteroid, look for resources on a comet, will have to buy their spacecraft. So I think
And
it's really clever. It's a really great way to kind of position yourself.
and Deep Space Industries, I mean, as much as I sound like I'm mocking their marketing team, they really do kind of like they're doing actual marketing, which we don't normally see in science. So they have a little tiny CubeSat that's water powered, and it's named Comet
Yes.
because it's water powered.
Yeah, it's a water-based propulsion system.
Yeah. And I just it's clever.
Yeah, but
It's
but imagine that future, right? Where you land
yes.
on a comet, you land on an asteroid,
It's a
water,
CubeSat.
you find water, and then you turn that water into propulsion, and you go land on another asteroid, and you just keep this going. So I think it's a really clever idea for traveling around in space from world to world with this renewable resource.
And this really is a hardware selling operation. They're the ones selling the shovels to the miners. They are advertising Comet as already approved on multiple launch vehicles. It's flight tested. Here you go. Let's talk money, folks.
They're two hundred
Um,
thousand dollars. You can buy your own Comet engine and attach it to your CubeSat for $200,000.
and so here we are. They have that. They're working on their Explorer. Um, I, as I said, am deeply amused at 2.5 AU, which is not to Jupiter being deep space, but that's okay. Um,
You get to 2.5 AU.
no, I'm too lazy.
Okay.
So yeah, it's this these are two different companies with two completely different business profiles. Deep Space Industries is working to sell the shovels to the people who are going to go out and do the mining. And I keep thinking this is also the place that like your university aerospace department can go to launch their next graduate students project. Um, then we have on the other side, planetary resources is like, we're just going to get this done. We're just going to go find you that water and define all the technologies that you need and keep going from there. So we have the one team that is basically the prospecting team, that's planetary resources. And then we have the team that's the shovel selling team, and that's Deep Space Industries.
Yeah, it's a pretty interesting state that we're in. And you can just imagine how things are going to accelerate. When SpaceX, for example, gets the BFR flying, or even the Falcon Heavy, you're going to be able to purchase space on that. And as long as you're willing to go to the asteroid belt like everybody else who's going to be on that mission, then you won't have to pay a lot to send. So you buy your little prospecting spacecraft, you put it on the BFR for a couple of $100,000, maybe $1 million. You're off to acquire resources from the asteroid belt, and maybe you're going to strike it rich. You're going to bring back that that beautiful spun gold and drop it back into the atmosphere.
What I'm waiting for is the day that premium automobiles, so like your BMW 6 Series and CubeSats, have the same cost. I think that's going to happen in the next decade or so.
Yeah, it's a cool time
Yeah.
to be a part of this, and I think we're all going to see this technology come a lot more quickly than I think we'd ever expected. We've spent so many years wondering when people are going to set foot on the moon again, but now when you're looking at SpaceX preparing to launch 5,000 satellites, 12,000 satellites just to provide us internet, the costs have come down, will be coming down dramatically. You're going to see utilization of the resources of the solar system happen a lot more quickly than I think we'd ever anticipated.
I'm waiting for the day when the science fair winners are getting CubeSats as part of their prizes, and when wealthy people put into orbit their own little security thing from space or something.
Yeah. All right. Well, thanks, Pamela. We'll see you next week.
See you. I am totally determined to like clobber
Yeah,
my
you
mic
really
today.
are smashing up that microphone. All right, hold on, everybody, and then we will get on to your questions. Pamela's answers.
And Chad, I already stopped my
He's gone. He
recording, so
can't hear
that was
you.
useless.
He'll never
Yeah,
hear you.
it's true. It's true. My ceiling fan was on, and I have this little tiny noise throughout the background.
All right.
Poor Chad.
So I've been working on an article. I'm working on a video about the 4 missions that are going to be in the decadal survey, and
You're making predictions.
I'm explaining the plans for the missions that they're going to be putting in the decadal survey. The 4 that are planned. There's the HabEx, which is the Habitable Worlds Explorer. There's the Lynx, which is sort of like a super Chandra X-ray observatory, and there's the OST, the Origins Survey Telescope, which is a super version of James Webb. It's going to have a 9.1 meter
Are
mirror.
you saying that they're going to fund another telescope that will never ever launch?
These are the next missions that are going to be proposed as part of the decadal survey. Everybody knows that everything goes into the decadal survey becomes a mission. And then the best for last is, of course, the LUVOIR telescope, which is going to be either an 8-meter telescope if it launches on, say, a Delta Heavy, or a 15-meter telescope if it launches on a SLS or a
I can
BFR.
only imagine the future where everything in the decadal survey actually gets
Yeah.
built and launched.
Yeah. And so, because they are, and because it will, these missions, all 4, um, the first 3, the OST, the Lynx, and the HabEx, are all going to be 5. They have a budget. They're going to try and keep their budgets under 5 billion, maybe even down to 3 billion. They'll try. And then LUVOIR is going to be a $9 billion telescope. Is their starting budget? So it's
Nine
all
billion.
9 billion is their starting budget. That's the budget that they're going to bring together this 15-meter telescope and put it into possibly a
So
Lagrangian point. It's going to be
so
the successor to the Hubble Space Telescope.
so what's NASA's yearly budget?
There is the the decadal. So here's how this works. Allow me, I'm going to mansplain this. I'm going to Cain-splain this for you. Keep in mind, of course, Pamela is one of the people who's involved in the decadal survey, while I am just a nerd fan. Yeah, so the budgetary allocation. Of course, this is all science fiction. Of course, God, right? But it is pretty amazing to think. And in fact, what's hilarious about this is that NASA just put out a press release saying, "Hey, everybody working on these next generation telescopes, rein it in now, because we're already over budget on James Webb. We're already kind of starting to move towards over budget on W first. So let's."
Have I mentioned that like my W first related project has already been canceled?
No, didn't know
Yeah.
that. Um,
Yeah.
but these and so the project managers know this is happening, and they have sort of ratcheted down the scales of their project. But each one of them is just like, I just read about it and I just want this telescope so badly, right? The HabEx has 2 coronagraphs on it. It's going to have one coronagraph built into the telescope, and it's going to have the star shade. And it's going to be able to directly image habitable worlds around other stars. The Lynx mission is going to have, I think, 3 times the aperture of Chandra. and is going to be have better technology for siphoning X-rays down into it using the method that they do. Um,
So, do you know what happens to the science budget when they start building big equipment?
I'm not listening. OST is, like I said, uh, 9 meters across. So while the James Webb is going to be able to see this era of reionization, see the first galaxies coming together, OST is going to be able to see the first stars coming in the dark ages. It's essentially the first era after the cosmic microwave background. And of course, LUVOIR is just going to be a Swiss Army knife of instruments from ultraviolet to infrared to visible light. So yeah. Okay, so tell me, based on your experience with the decadal survey, what do you think will actually come together? Now, they're all supposed to launch by 2035 is the plan. So what? So now, don't be super grim. And I think is James Webb the perfect example? Because I mean, you look at Chandra and you look at Spitzer; those didn't run
No,
immensely over
no.
budget. You look at WMAP, you look at Planck, you look at Fermi, you look at, there's a lot of missions out there that have come together, maybe have gone over budget, but have.
So the specific problem with James Webb is it was designed to fit a specific kind of rocket that required it to fold itself up. And this is an untried technology that many of us had hoped had been employed in spycraft, but I'm thinking if it had actually been used for spy satellites, that they wouldn't have had so many bugs to work out. Um, so
Yeah.
it's impossible to realistically budget how long it takes to innovate something that has never been done before and get it space ready with enough assurance and do it within all of the various holds and paperwork needs and random chaos that has occurred due to federal budgeting issues. Um, it's hard to figure out how much that will cost. And one of the things that has really affected James Webb that I don't think people have really thought about is every time they put a hold on James Webb, they've got to move the staff that are working on James Webb to other funding lines.
Mm-hmm.
So all of your grad students, you're suddenly rehoming. All of your postdocs, you're suddenly rehoming. Your engineers are moving on to other spacecraft. And so then you have to keep building and collapsing and building and collapsing. So they're adding all sorts of overhead costs onto it. By extending how long it's going to take before launch, you have to keep all of your clean rooms clean. You have to handle all of the storage costs. It's super expensive to have an unlaunched spacecraft. We just need to launch it someday, please, sooner rather than later. And all of these difficulties are eating away at the budget that NASA has to use on other things. So for a while, ALMA, when it was under construction, Curiosity, when it was under construction, and James Webb, which is still under construction, were eating up roughly 30% of the entire astronomy and space science community's budget, just with these three different facilities. And these facilities weren't as expensive as what you're talking about.
Mm-hmm, mm-hmm.
Now, we're hitting the point where, in order to make great strides forward in science, we need to build great facilities. So there is a need for the kind of instrumentation that you're talking about. The question is, how do you balance the fact that every facility has its own advocates going and saying, we cannot close, name your telescope.
Mm-hmm.
So we have all the same existing facilities costs. Salary is hopefully going up. I mean, reality is it's not for scientists. So we're essentially taking steps backwards year by year. Property and all, and poor Arecibo, they got wiped out by they didn't get wiped out. They got $2 million worth of damage from a hurricane They got lucky. NSF is going to repair them. But we've seen all sorts of just random stuff happens. Buildings get leaks, critters get in.
Hmm.
You have to pay for all of that. So if you never allow anything to shut down, if you want to build new facilities, the only place left to take that money from is from the money to do science. And this is where we see in Europe that they have the European Space Agency's funding for spacecraft is completely separate from the funding that scientists subscribe for in order to do science. And by keeping these two separate, they've been able to protect to a certain degree the grant lines. We don't have those projections, and it's getting harder and harder to get federal grants to do science. So my black, dark, two sizes too small, soft money surviving heart, every time I hear about new super expensive facilities, I'm like, expletive. My ability to keep my job just got harder.
Right.
So it's what we need is better funding of infrastructure in the United States, including our science infrastructure, our bridges, our roads, and maybe fewer wars, maybe.
Yeah, of course. I mean, NASA's whole budget. Someone was saying in the chat, NASA's whole budget is an aircraft carrier. The F-22 Raptor is whatever $1 trillion of development. Obviously, right?
Yeah.
And yet Hubble just celebrated its 28th birthday. It is not going to be with us forever.
No.
And then what do you have as a space-based visible light telescope? Nothing.
Yeah.
Right? So absolutely.
Well, we still have VLT. I mean, the thing to remember
Sure,
is
ground-based telescope.
VLT is for many different tasks actually superior to Hubble, and people just don't talk about that because VLT does not have nearly as impressive a press engine as ESA and NASA have managed to put together with their combined forces.
I would say that's not true. I would say the European Southern Observatory's press office is the best. I'd say they're as good as Hubble's. Like when I see the kinds of press releases that they put out, the quality of the discoveries they've made, and I think you're exactly right. I mean, I think that there has been a round of instruments that they've attached to the VLT, like the espresso instrument and the sphere instrument. They put a coronagraph on it. They've built this really powerful spectrometer that we're going to see some of the kinds of discoveries that we would have waited for James Webb to make coming out of the VLT and the Magellan and some of these next generation large ground-based telescopes.
And I completely agree with you. The quality coming out of ESO is probably the best in the world when it comes to this is how you do press releases right. I don't think anyone has the quality they have. I think what they're missing is the name recognition that comes with Hubble, the Lego toys that come with Hubble, all of this stuff, the calendars that are available in every single shopping mall November through January.
Yeah.
ESO lacks the merchandising.
The merch. There you go.
And so they don't have that mainstream. Every little kid doesn't say, well, I guess little kids don't say about Hubble either. Every college nerdy geek doesn't have an ESO picture on their wall. They have a Hubble picture on their wall.
Even though the ESO pictures are as nice as Hubble.
And sometimes better.
Yeah. Did you see that one that came out of the Tarantula Nebula a week ago? Just unbelievable. Yeah.
Yes. I have to say, though, on that, the Tarantula Nebula through a 16-inch telescope is creepy as all get out and looks like a spider face.
Oh, wow.
And the more resolution you add.
Uh-oh. What if she got hit by a tornado? Hope not.
Stable. I was ranting too quickly about the tarantula.
Yeah, that was
sorry.
It. All right. You're back.
Okay.
We should take a couple of questions before we wrap this up.
We went down one hell of a rabbit hole.
I think mine. Am I back?
It says you're back. I hear you.
Okay. No, but I wonder if the people. It looks like there was like a glitch in the actual YouTube. So.
Oh.
Yeah, I think we're back. And people are seeing a buffer, but it's no longer dropping any frames. And you,
okay?
I think my internet went crazy for a second there. All right, questions. I want to get some questions from some people. So, John Seffield asks, couldn't NASA pass on the running of Hubble to another space agency? I mean, they can, but that's not the problem.
I don't think Congress would approve such a thing, first of
Yeah.
all. And it's already jointly administered with ESA.
And once these missions go up, the running budget
Yeah,
is
that's not
fairly
that bad.
insignificant compared
Yeah.
to just the building and the launching. So they always threaten to. Like we just found out that Juno just got its mission extended. Big surprise. Right?
That was actually a slightly more complicated issue because uh, they were having engine stress with their 14-day orbit, and their ability to complete their science is based on number of orbits, not number of months in orbit. And to put themselves into a less straining set of maneuvers, they needed to extend out to a 50 something day orbit, which meant they needed an extra 40 something months in order to complete the number of orbits they need to complete their science goals.
But it's not as if someone was about to turn off all the computers and just shut down and cease all communication with Juno.
They kind of did that to Wise.
Yeah. Wise came back, and then it got a new name. So, okay. So Arjun says, "Isn't the decadal survey a step in the right direction as far as funding goes?" Like,
Things don't get funded if they're not in the decadal survey,
yeah,
but things that are in the decadal survey don't necessarily get funded. So we've been requesting a spacecraft to go out to Uranus, Neptune. Not going to happen anytime soon. One of my strongest memories is of going to it would have been the 2003 Lunar and Planetary Sciences Committee, and seeing, I think it was Yvonne Pendleton, but I could have this wrong, giving the NASA town hall, and was like, here are the things that were requested in the decadal survey. And then she slide by slide went through and named the funded missions that matched every single need in the decadal survey. Now, fast forward to the late 2000 aughts, and most of those missions were canceled.
mm-hmm. Yes. Larry Beckham says, "No tax dollars to break through Starshot. It's ridiculous." Well, don't worry. It's Yuri Milner is paying it out of pocket, so don't worry about it. In fact, they just put out the contracts to get people to build them.
Really, that's
Yeah.
awesome.
But so just back to to what you said, right? That nothing gets done if it isn't in the decadal survey, and the decadal
Yes.
survey is the way that scientists tell Congress what
This
their
is what is
priorities
scientifically
are.
responsible to build.
Yeah. These are the big questions that we require answers. These are the next answers that we need to go looking for. And obviously then there's all kinds of horse trading and all kinds of cancellations and all kinds of stuff that happens from that point forward. But you do get WMAP is in space.
And
right?
we do have issues
Spitzer.
with Congress, and the executive branch can at any time light item, fund, or cancel. So the Fermi Gamma Ray Observatory, back when it was glassed, was actually canceled by NASA to conserve funding for other projects. And the Congress critters out in California that had most of the funding for GLAST in their district got involved. There was a letter writing campaign. People basically got the science committee involved, and NASA was informed, thou shalt not cancel this spacecraft. And there was a kind of epic AAS NASA town hall in which we were told that if we didn't behave, we'd be sent to the children's table for going to Congress to get our funding fixed.
Right.
So NASA bawled our butts out, and Phil and I both have old blog posts on that because we were both sitting next to each other blogging this to see who could post first.
Yeah, and you weren't
No, 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 no. We as a
chastised.
community
Yeah.
were told we'd be sent back to the children's table. So Congress can make NASA do things. And then we also have to worry about Congress taking things away. So W First is having a rough year because depending on where you are in NASA and where your authority comes from, executive branch or congressional funding lines, um, you have a different ability to interact with W First.
Right. All right, so we're running a little long, but we kind of had a little more. We started a little late, so we wanted to just give you a little bit of additional information. I want to do one last question here. This comes from Anti-Fusion. Do you have any info on what exactly would keep astronauts safe from cosmic microwave background radiation? Really, you're talking about cosmic galactic radiation. When serving for months on end in the Deep Space Gateway, doesn't landing and living under regolith domes make sense?
It really does. I don't actually know how they're planning to keep people safe at the Deep Space Gateway, which is built in cislunar space. So it may actually be just inside the Earth's magnetic field. I don't know. It's just that simple. If you're on the surface of the moon, yes, you do need to have an escape shelter to climb into. Now, it's possible to build these whenever there's particularly nasty radiation coming at us from the sun. The astronauts seek shelter in the Soyuz capsule. It's just a little better insulated than the space station as a whole. So I'm sure that they'll have these emergency take shelter locations. And with the moon, they'll probably have both take shelter on the surface locations. Like in my mind, you can imagine having essentially what look like porta potties strewn across the surface of the planet, which are emergency shelters for astronauts on walkabout.
Yeah.
Um,
Because you only got a couple
now,
of minutes notice sometimes that a powerful solar storm is coming in.
and you're going to need to have emergency shelters long term anyways in case something happens to your spacesuit, if you like have an oxygen leak. There's lots of good reasons to build emergency shelters. Hopefully they won't actually look like porta potties. I'm thinking more New Zealand yurts would be awesome. uh, but yes, we're going to want to build our primary bases underground. Lava tubes are one of the things that gets discussed
Yep.
most, also digging into the sides of crater walls.
Yep. All right. Well, I think it's time to wrap up this week's episode. Thanks, everyone, for joining us. Thanks, Pamela, for bringing the brain. Thanks to the WSH crew for running the chat. If you want to be a part of that amazing community, go to wshcrew.space. And they will hook you up. And remember, in that dark summer hiatus, you're going to need people to nerd out about space with, and they've got your back. So
and CosmoQuest on Twitch. CosmoQuest X is a user on Twitch.
We'll be around. You'll see us. But 2 or 3 more episodes. Someone should tell me exactly how many episodes that is. There will be some number less than 4 more episodes until we wrap up the end of this season. All right. Thanks, Pamela. We'll see you all next week.
Bye-bye, everyone.